Hello, this is video number 27 on my single variable calculus 2. In this video, we're going to talk about polar coordinates. So as you have learned in Algebra 1 and Algebra 2, we can represent every point on the xy plane by two coordinates. Let's say you have a point 2, 3. So when you drop the line to the x-axis, you get a distance of 2 to the origin, and it's to the right of the origin, and you get a distance of 3, and it's above the origin on the y-axis. Now, this allows us to write down equations of some curves really nicely. For example, every line would have a form of y equals mx plus b, or x equals a constant. So it has a really nice equation. Every line has a nice equation. Now, some curves are easier to represent using other types of coordinate systems. And in this video, we're going to talk about a different coordinate system. This is called the polar coordinate system. So what are the polar coordinates of a point? And this is going to be really useful in multivariable calculus as well. So the polar coordinates are the distance of a point to the origin, that's called r, the distance to the origin, and the angle that this ray makes with the positive x-axis. Now, the relation between the x, y, and r and theta are very important. So what are those relations? If you look at the triangle OHA, you can write down sine of theta as opposite, which is y, over hypotenuse. R is the distance to the origin. We can write down cosine of theta as adjacent over hypotenuse, tangent of theta as opposite over adjacent, and then by Pythagorean theorem, we can write down that x squared plus y squared is equal to r squared. Now, if we cross multiply, we get these four important formulas. X equals r cosine of theta, y equals r sine of theta, tangent of theta is y over x, and x squared plus y squared is equal to r squared. Let's do a few examples on that. Cartesian coordinates of a point are -1 and 1. We want to find its polar coordinates. So let's graph this point. The x coordinate is -1. The y coordinate is 1. So it is going to be right here on the plane, and we are trying to find the distance to the origin. By the Pythagorean theorem, the distance would be √2, and then we have to find this angle. Well, this is a 45, 45, 90-degree triangle, so that's pi over 4, and then plus pi over 2, so theta is 3 pi over 4. So one of the coordinates, one of the polar coordinates of this point are √2, 3 pi over 4. We could also find other types of coordinates for this point. For example, if you look at this angle is -5 pi over 4. It's negative pi plus negative pi over 4. So another representation of this point in polar coordinates is √2, -5 pi over 4. And of course, there are other representations of this point as well. So as you see, it is not like the xy coordinate system that for every point you have exactly one pair of coordinates. You could have multiple pairs of coordinates. You will have multiple pairs of coordinates. Here is the next example. The polar coordinates of a point are 3, -2 pi over 3. We want to find its Cartesian coordinates. So we know that x is r cosine of theta by the formulas that we got up there, and y is r sine of theta. So this is 3 cosine of -2 pi over 3, and this one is 3 sine of -2 pi over 3. Well, we can look at the unit circle to find the cosine and sine of the angle -2 pi over 3. So -2 pi over 3 is an angle like this. It's in the negative direction, -2 pi over 3. So it's in the third quadrant, which means both sine and cosine are negative. Sine of pi over 3 is 1/2, so this is -1 over 2. And I'm sorry, cosine of pi over 3 is 1/2, so that's -1 over 2. And this one is -√3 over 2. So the coordinates are -3 over 2 and -3√3 over 2. So this is the answer to the problem. Let's look at the next example. So write each of the following Cartesian equations in polar. So what we need to do is to replace x by r cosine of theta and y by r sine of theta. And this is actually pretty straightforward. So we get r cosine of theta, all of that squared, because that's x squared, plus r sine of theta, that's y, equals 2. And then we're going to simplify to r squared cosine squared of theta plus r sine of theta equals 2. And that is the answer to this problem. The next one is xy. So all we gotta do is to replace x by cosine, y by r sine, x by r cosine, y by r sine, and then x on the other side is r cosine. And if we simplify, we get r squared cosine of theta sine of theta minus 1 equals r cosine of theta. And that's the answer to this part of the problem. And finally, we'll do another example kind of in reverse. We have polar equations of curves as r equals 2 and 4 sine theta plus 2 cosine theta equals r. And we want to identify these curves, turn them into Cartesian. So the first one can be written as x squared plus y squared square root is equal to 2, which gives us x squared plus y squared is equal to 4. So what is that? This is a circle with radius 2 centered at the origin. And it was also kind of clear from the beginning because the distance to the origin is 2. So that's exactly the definition of a circle. The circle is the set of all points with a fixed distance to the center. So it is this circle. Let's look at the next part. For the next part, in order to turn it into Cartesian, we'll have to figure out where sine of theta and cosine of theta appear in the equations that we discussed before. So we see that cosine of theta appears here. So cosine of theta is x over r, and sine of theta appears in the equation for y. So sine of theta is y over r. So we're going to substitute. We get 4 times y over r plus 2 times x over r equals r. We're going to clear the denominator. We get 4y plus 2x equals r squared. R squared is x squared plus y squared. Now, what is this curve? Well, if we complete this square, if we see what the curve is. So this is x squared plus y squared. I'm going to move 2x and 4y to the right of the equation. So we get this equation. And then we're going to complete this square. So we have x squared minus 2x. So we need to add 1. So we get x minus 1 squared plus y squared and negative 4y. We need to add 4. 2 squared is 4. So that's y minus 2 squared. And on the other side, we have 1 and 4. So what is this? This is a circle centered at 1, 2 with radius root 5. So that's the equation, and this is the description. And we can see that it would look like this. So the center is 1, 2. So this would be the center. The radius is root 5. So it actually does go through the origin. So it looks something like this circle. Okay, so let's summarize what we have done in this video. We talked about polar coordinates in this video. It's a new system that assigns a pair of numbers r and theta to every point on the plane. R is the distance to the origin and theta is the angle with the positive x-axis. The relation between x, y, and r and theta are given by x equals r cosine of theta, y equals r sine of theta, tangent of theta is y over x, and x squared plus y squared is r squared. And that brings me to the end of this video. I will see you in the next video.